Okay, this page gives an idea of where we're headed. This green graph right here is the graph of g of y equals ln of 8y over 2y. Y has to be greater than 0 because you cannot take the ln of a non-positive number. If you try to do implicit differentiation from right here, I think you'll be headed down a rat hole. So my suggestion is to solve this for x and then differentiate with y with respect to x. This is actually the first derivative here, which I'll show on the next page, and this is actually the second derivative. And we want to know, when does the second derivative equal 0? And that actually looks like that's going to give us a point of inflection right here. In other words, the concavity has changed from concave downward to concave upward at that point. And it looks like this is the y value that helps us find out when the second derivative is equal to 0. There it is. Okay. So how do we find these derivatives? Well, again, I've defined the function this way. So I'm going to use the quotient rule on the left. And here's where I am finding y prime. I'm not going to go through every step. Pause the video and take notes. But I use the quotient rule. And the derivative of x is just a 1. And there's the first derivative. Hopefully you can follow along with these steps. To find y double prime, I'm going to take the derivative of y prime. Again, using the quotient rule. So denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is going to be minus 1 over 8y times the derivative of the inside chain rule, 8y prime. That simplifies like this. Then the key is I replace this y prime with this expression right here and simplify. So here, these cancel out. And then to get from this step to this step, I multiply numerator and denominator of this fraction by 1 minus ln of 8y. And that gets rid of this complex fraction. So I get 8y cubed times what I multiplied top and bottom by, 1 minus ln of 8y, plus 4y cubed over, that denominator is now cubed. And then if I distribute this 8y cubed, combine similar terms, there's what I get. And now I want to know, when does that second derivative, when does y prime equal 0? Well, it only equals 0 when the numerator equals 0. That's one way to think about it. If I factor out a 4y cubed, I get 3 minus 2 ln of 8y equals 0. That means that y could equal 0, which is rejected because y has to be greater than 0 for this function definition. But then this factor could also equal 0, which if I set that equal to 0 and do this, then exponentiate after dividing both sides by 2. E to the 3 halves equals 8y, so y equals e to the 3 halves over 8. That's the y value of the y coordinate of the point where the second derivative is equal to 0, point of inflection. Now, how do you find the x value? You just substitute this in for y, and there's the x value, 6e to the minus 3 halves. So there's your answer right there. And once again, that's a point of inflection. I put a tangent line here to prove that the first derivative was correct. And you'll see if you visit the Desmos graph that I've got a slider for y, and it can show you the different positions of the tangent line. So there you go. Hope that helped. Any questions, post a comment.